Let me see whether I can write on here. No. We have a whiteboard. Let me check that. I can show you this, but at the same time, I want to try whether I can. It's going to allow me to use the whiteboard as well. Let me see. Probably it's not going to. Okay, that's fine. All right, so I'm going to. Okay, I am going to go over the lecture notes, and when we are solving a problem, maybe I'm going to go to the whiteboard to write on. Okay, functions and their graphs. So what's a function? The function is formally defined as follows. So it is. You can consider this as a machine. Function f is a machine. Okay, we have a domain D and we have another set y, which we are going to call the image. So, and the function f, the machine has a rule. So it's going to take points from the set D, domain D, and it's going to assign a unique number, which we call it f of x in y. Okay, for each x, we are going to have f of x, which is defined by using that rule. Okay, so this is the definition of a function. You can see the picture-wise, the pictorially you can see it like that. So we have an input x, it comes from the domain, and f is the rule. The function f is the rule, it's telling you the rule, and according to this rule we have an output. We call it range, and the range is called f of x. Okay, so this diagram should be very clear for you. Okay, this is another picture. This picture is actually, we just use this D as the domain, and these are the elements in the domain D, and we have X, as you see, we have A and other elements which we don't explicitly say what they are, and we have a Y set. This is a set too. This is a set, this is a set. And this y is going to contain the range in it. Range means, for example, f of a is an element in range. F of x is an element in range. Okay? Görüntü. Okay? Image. All right? So a function from a set D to a set Y assigns a unique element of Y to each element in D. Okay? You can consider this f as a machine like that. We have some very well-known functions. So we have a y is equal to x squared function. I wish it would allow me to draw here. It doesn't. Okay, let's see. I will give it a try again, if I can. If it's going to help me to write. Okay, let me see whether it's going to allow me to write. No. Yeah, I tried a couple of times. It didn't allow me to write. That's okay. That's okay. But anyways, I'm going to write. Just a sec. Let me take it out. Okay. Right. So we have some functions. We need to know them, their pictures, etc. And their the domains respectively and their range. So for example, y is equal to x squared has the domain everything in it. And the range is from 0 to infinity. It's not going to take the range. The image is not going to have the negative values because we have x squared. X squared is positive or 0, right? So because of that, the range can never have negative values in it. And a 1 over x function, y is equal to 1 over x function. The domain cannot have 0 in it because 1 over 0 is undefined. Yeah. So the domain is everything except 0. And the range is going to be everything except 0 as well. It's we are going to call it butterfly function. The picture is kind of butterfly. I'm going to show the pictures later on. And y is equal to square root of x. This square root of x has the domain all non-negative numbers, because if you put x as a negative number, square root of negative is undefined. Therefore, the domain is everything greater or equal to 0. And the range, because of that, is everything greater or equal to 0. Y is equal to square root of 4 minus x. What is the domain? Domain is going to be everything between negative infinity and 4. And you can ask why. because we have square root of 4 minus x. So the x can be any value equal to 4 and negative value, so that the inside becomes a positive value. So I'm going to tell you that as well by drawing. I'm going to draw them to you. And the range is going to be 0 to infinity as well. And this one is a little bit trickier because the domain cannot be outside -1 and 1. Because if you take any value outside of -1 and 1, let's take 1, for example, let's take 2. If x is equal to 2, 1 minus 2 squared is negative, and square root of a negative number is undefined. So because of that, the domain has to be between -1 and 1. And the range is going to be 0 to 1 because these values are going to be small numbers. So square root of that small number is going to lie in here. Okay, these are nice examples. We have to draw them as well. Maybe the graphs are coming up. Let's look at this graph. The graph y is equal to x plus 2. This is just a line. Okay, what's the domain of this function? The domain of this function is everything, all x values. Okay, there's no restriction on the function. This is our machine. The machine says take an element x and add 2 to it, and you get the image. Okay, and the picture is just this line. And line, how would you draw a line? You should look at the slope of the line, which is 1. This is a line with the slope 1. Okay. Actually, this is a shifted line of y is equal to x. I'm going to tell you that too, pictorially. And this is another function, the graph of a function. Okay, so how do we understand that graph? For example, at x is equal to 1, f of 1 is going to give you the height of this graph. At x is equal to 2, 2 is going to give you the height of that graph. At x is equal to x, this is the height of that graph, but it goes to the negative values. That's how we draw the graphs. Graph the function in example 2. What's the example 2? Excuse me. You are given this table and they want you to graph it. Okay, you are given, or maybe, I don't know, let me double check the example 2. Excuse me. Probably in example 2, I don't have the book with me right now, but they're asking you to draw the graph of y is equal to x squared between -2 to 2. And how would you draw that graph? This is a parabola. I'm going to tell you how to draw the graphs of parabolas easily. But right now, this is our first class. We are just refreshing our minds, our knowledge from high school. If you have y is equal to x squared, you build a table. You take some values of x and put it in the machine. This is the rule of the machine. You're going to square it. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 3 over 2 squared is 9 over 4. 2 squared is 4. So you have this table, x values and the corresponding y values. And then you just plot them in the graph. So -2 to 4. -1 to 1. 0 to 0. 1 to 1. 3 over 2 to 9 over 4. 2 to 4. What you would do is you're going to combine all these, okay? But you're going to do it in a curved way because x squared is a curve. It's not a line. Then you combine all these, you get this picture, which is a parabola opening upwards, okay? Okay, any questions so far? Let me check the questions. Okay, any questions so far? Okay, so we continue. If you don't have any questions, okay, this is just a start, okay? So we are going to come back to it time to time. So don't think that this is all of it. And let's see. This is another example. I'm going to skip that. So this is an important example. So we talk about the circle and semicircle here. So circle has this equation you remember from high school, x squared plus y squared is equal to 1. This is the unit circle. We call it unit circle. Do you want me to make it a little bit bigger, maybe? Okay, let's make it bigger. Okay, so this is the unit circle. And we have the semicircle. Look at that. If you factor out y from here, you get y is equal to plus and minus square root of 1 minus x squared. So actually from this, we got two functions. This is one function, this is another function. And what are the graphs of those? The graph of this is actually top semicircle, and this is the bottom semicircle of the circle. So these two forms the circle we have. Now, this is a function, this is a function, but this is not a function. This is actually a relation. We call it relation. But what is a function and a relation? We have a rule, which is the vertical line test. Vertical line test tells us how to differentiate a function with a relation. Okay, what you would do is you're going to draw a vertical line on the graph. Okay, if the vertical line intersects more than 1 point, at more than 1 point, okay, if it intersects the graph at more than 1 point, then this is a relation. This cannot be a function. But look at this. If you apply the vertical line test to it, it's going to intersect our line curve at just 1 point each time. Okay. Similarly here, draw a vertical line, and it's going to intersect our graph at single 1 point. So this is a function, this is a function, but B and C are functions, but A is not a function. All right. A is not a function. It is called a relation. Okay, so this is something we just learned right now. Okay, let's move on to the next page. Okay, this is a very famous absolute value function. Okay, mutlak değer fonksiyonu, absolute value function. Absolute value function is a V-shaped function. It's a very nice function. Y is equal to absolute value of x. It is defined on all of real x's. So the domain is everything. The domain is all real x values. And what is the range? The range is 0 to infinity. How would I know? How would I find that? Because the absolute value of x has this rule. So if you take the absolute value of any number, it's going to be either 0 or greater than 0. Therefore, because of this, we know the absolute value of x has to be, the image has to be 0 to infinity. Okay, no negative values as in the image because of that. All right. This absolute value of x, we are going to come back to it again because it's important. Here's another function. Actually, this function is made up of a couple of functions. For example, for x values less than 0, we take this function y is equal to negative x. Between 0 and 1, we take the function y is equal to x squared. And between 0 to infinity, we take the function y is equal to 1. So we take 3 different functions and we combine them in a way that we got this function. Okay, let me check something. Okay, no comments. All right. Okay, so there's a nice question from Ömer Faruk Akgeyik. Ömer Faruk says, teacher, sorry, I wonder why don't we have complex numbers as a function? Yes. Now in calculus, we don't really work with the complex numbers. We only work with the real numbers. When you guys take, especially electrical engineering students will take, and mechanical engineering students as well, complex numbers in the future, they use it a lot. And complex analysis, then they are going to have functions defined using complex numbers. But in calculus, we don't have them. Okay. So in calculus, I want you to forget about the complex numbers for now. Okay. But in your future classes, if you're in electrical engineering or mechanical engineering, you can have classes on complex numbers, complex analysis. That's a good question. Thank you, Ömer Faruk. Ömer Faruk, do you have a brother, Fatih Akik? Is he your brother? Fatih Akik, do you have any relationship between? Ah, okay, good. Is he your brother? Or a relative, maybe? Okay, okay, say hi to him. Great, say hi to him. We worked with him on a project together. Okay, yeah. All right, let's continue our class. See, these type of functions are called special. These are called piecewise functions. Maybe I should write somewhere. Let's see if I can write it here. Let me see. Piecewise functions. These are called piecewise functions, okay? Let me make it a little bit bigger for you. Okay, these are called piecewise functions. It's made up of pieces, okay? It is made up of pieces. Each piece is a function, okay? Each piece is a function. All right. Okay, so this is my comment. Let's see whether I can move this anywhere. Yeah, I put it in here. All right. This is my note. Note from the professor. All right. These are called piecewise functions. How many pieces does it have? 1, 2, 3 pieces. Okay. Okay, that's very nice. That's fun actually to use more functions to form one. Okay, next page. That's my next page. How am I gonna get to it? Just give me 1 sec. Okay, let's go back to previous one. I don't want to, okay, yeah, everything's fine. This is another function which we call it greatest integer function. See, there's this greatest integer function here. All right, let me see whether I can highlight that. Yeah, okay, this is called greatest integer. No, it doesn't do that. Anyways, maybe I should just continue typewriting it. Okay, greatest integer function. This is called this is called a step function. Note. This is called a step function as well. Step function. This is like steps, right? Step function. Look at the steps. 1, 2, 3, 4, 5. What is the rule for the step function? We should always remember the rule. The rule here says, okay, greatest integer of a number, for example, greatest integer of 3.4. 3.4 is going to be equal to 3. Okay, it takes the whole numbers. If you have a 3.4, it's going to be equal to 3. Okay, if you take, for example, it's going to take the whole number value that's smaller than itself, but the greatest one, the greatest of them all, because you can find a lot of integers less than 3.4. For example, 3, for example, 2, for example, 1, for example, -5, etc. But you're going to take the greatest of them all, and 3 is the greatest of them all. Let's say, for example, 1.8. All right, greatest integer of that. Okay, so we look at the integer numbers that's less than 1.8, but the greatest of them all, it is going to be 1, right? But how about this negative number, -2? What's the greatest integer for -2? Is itself. If the integer, greatest integer is itself. But how about greatest integer of -2.1? What is that? The greatest integer of that is going to be, is it -2 or is it -1? Which one? Can you tell? What's the greatest integer value for -2.1? Is it -2 or -3 or -1? Which one? Is it -1 or -3 or -2? Which one? Anybody can say?
-3.
-3, yeah. It's the smaller one. Yeah, can you turn off your microphone now after you're done? Thank you very much. I appreciate that. Otherwise, it's echoing. Thank you very much. That's right. That's -3 because you're going to find a number that's less than integer. That's going to be less than -2.1, but it's going to be the greatest of them all. For example, -3 is less than -2.1. But -1 is not less than -2.1. -2 is not less than -2.1. So these are not going to be right. And -3 is the greatest of them all. Okay. So this is a nice note here. Let's continue. We are just brainstorming right now, okay? Okay, these are the things maybe most of you know, but we are going to go over and we are going to solve some problems on them later on. So we have some definitions. Right. So we are going to have a function f. We are going to say a function is increasing if, as you move towards right, the function is getting bigger. Then f is increasing. We are going to say a function is decreasing, on the other hand, it's going to go down if you move towards right. Okay? So these are the formal definitions of these increasing, decreasing functions. Let me see whether we have examples on that. Okay. Okay. Let me see a nicer example here. We don't have that here. Okay, let's look at this picture for increasing, decreasing function. Actually, this function, for example, on this piece until 0, it is decreasing because it's going down. As move towards right, the function is going down. Between 0 and 1, the function is increasing. It is going up. Okay, if you move towards right, it is increasing until 1. But after 1, it's a constant function. Okay, just give me 1 sec. I need to mute myself a little bit. All right, I'm back with you. Sorry about the break. So you can easily see this function is actually on this piece until 0, it is decreasing. Between 0 and 1, it is increasing. And after 1, it's a constant function. It doesn't increase, it doesn't decrease, but it just stays the same. All right, it's a constant function. We call it constant function. So here, let's write it here. Okay, it is decreasing until x is equal to 0. Okay, and then here we can write increasing. Let me see, increasing between 0 and 1. Okay, it is constant. If it's constant after, okay, or maybe for x greater or equal to 1. Okay, It's a constant function after that. It's increasing between 0 and 1. The function is increasing between 0 and 1. It is decreasing until x is equal to 0. From negative infinity to, maybe I can write this here, decreasing on, okay, decreasing on, I can write it like that, on negative infinity, all right, infinity to 0, right? I can include the 0 as well here, okay? I can write it like in intervals like that, okay? Here I can say 0 to 1, okay? Let me, namely, I can add here, namely, on 0 to 1. 0 to 1, I can say that, okay? Similarly, I can here add, okay, namely on, I'm gonna say 1 to infinity, right? I'm gonna say that infinity, right? Positive infinite, this is negative infinite, right? I can say all these. All right, so let's move on. Let's move on, increasing, decreasing, we talked about. Okay, I think I'm gonna stop right now here. We are gonna talk about the even function, odd function in our next class. Okay, I think there's a conversation. Teacher, the graph under the x, all of them change. What did you say? Osman Burak, can you say what do you mean? I didn't understand. Can you explain? In which graph? The one, the piecewise function are you talking about? Is that what you want? Is that what you're talking about, Osman Burak? If you can speak in Turkish if you want. I couldn't get your question.
Can you repeat the question again, please?
What do you mean, Osman Burak? Okay, probably he, we don't, maybe he's gonna ask me later on, I don't know. Okay, anyways, so let me get your questions before I leave. Do you have any questions about the parts we discussed? Of course, this is, some parts you may not immediately understand, I understand, but if you have any questions, let me know right now. We can go through the parts that we discussed, and we can talk a little bit more. Because we have 8 minutes, we can discuss your questions. Okay, I'm going to share the slide with you. Okay, guys, and you can ask me questions from there later on. I want you to say bye in the meeting chat so that I have a recording of you, that you were here till the end. You can say just write bye in the chat. Fırat, okay, you have a question. Go ahead.
Merhaba hocam.
Merhaba.
Nasılsınız?
İyiyim. Siz nasılsınız? Buyurun.
Ben deyim, teşekkür ederim. Hocam ben dersi yükseltmeye aldım da attendance %5 etkiliyor demişsiniz. Benim dersim beton dersiyle çakışıyor da bir saat
Fırat,
kadar.
Güzel bir soru sordunuz. Sizin %5'e dahil olmanız ne kadar çakışıyor? Bir saat mi?
Hocam bir saat çakışıyor.
Diğer saatlerde gelirseniz sorun olmaz. Ya da şu hakkınızı kullanabilirsiniz. F olduğu için sizin notunuzda o %5'i iptal ederiz.
Tamam hocam. Hocam bir de syllabus'ta homework yazmıyor. Homework'ler katılıyor mu acaba?
Notlara homework girmiyor ama homework'ten ekstra bonus alacak yapanlar.
LMS üzerinden mi olacak homework?
Homework MyLab üzerinden olacak. MyLab'de yapacaksınız.
Tamam hocam, teşekkür ederim, sağ olun.
Teşekkürler, sağ olun. Evet, çok teşekkürler. Osman Buğra, buyurun. Yes, please.
Hocam biraz önce bağlantı problemi oldu da şey demek istemiştim. Grafik x eksenin altında olmuş olsaydı bu sefer her şey tersine dönerdi değil mi? Yani görüntü, aralık.
Tabii. Artma, you mean increasing, decreasing, right? You're talking about increasing, decreasing or what? Görüntü olarak mı düşünüyorsunuz?
Yes, evet.
Yes, of course, yeah. If it's taking y values, then it's going to be. Which graph are you talking about? Which page? Do you remember?
I don't remember, teacher.
Okay. Yeah, if the function is taking negative values, then if a function, he's talking about the image, I guess. But you have to give me a concrete example. Are you talking about absolute value of x, maybe? Hangisi tam olarak hani örnek üzerinden gidersek sorunuzu daha iyi anlayabiliriz. Çünkü böyle konuştuğumuz zaman örnek üzerinden konuşmazsak kafanız daha da karışır.
Bir önceki sayfada kalmıştı.
Hani ben bir graf efendim?
Bir önceki sayfada kalmıştı o bahsettiğim kısım. Bundan bir önceki sayfada.
Hangisi?
Grafiğin olduğu kısım. Evet, burası. Yok.
Şu değil mi?
Evet bu. Evet.
Şu piecewise olan mı?
Bu hocam, bu.
Are you talking about the piecewise function?
Yes.
Are you talking about this function?
Yes, teacher, this function.
Okay. What do you mean by below x? What do you mean? Like if this graph was below x-axis, is that what you mean? Türkçe anlatın isterseniz bunu. Ben net olsun yani neyi anlamadınız burada ya da neyi düşündünüz?
0 ile 1 arasındaki artan kısım x eksenin altında olmuş olsaydı bahsetmiştim.
Simetrik bir şekilde mi olacaktı? Simetrik iz düşümüne mi bakalım?
Evet, simetrik iz düşümü.
Evet, simetrik iz düşümüne bakarsak decreasing olacaktı. Evet.
Okay, thank you, teacher.
Teşekkürler. Okay, so I think I answered this question. Let's go back to. Okay, there's another comment, I guess. Fred Bayer, okay, bye.
Hocam bir şey daha sorabilir miyim?
Tabii ki. Go ahead.
Hocam ben 10 tane ders alıyorum da biraz karışık programım. Konu listesine ulaşabilir miyim acaba syllabus'tan?
Konuların isimlerini mi?
Evet.
Konuların isimlerini yazarız. Syllabus'ta yazmıyor. Kitabın şeyleri var. Onu gönderirim ben size. Siz bana bir e-mail atın.
Tamam
Konu
hocam,
başlıkları
atayım ben size. Evet hocam, konu başlıkları önceden çalışayım da 10 ders var. Altına kalkamayacağım yoksa.
Okey, tamam.
Sağ olun hocam.
Teşekkürler. Thanks. Okay, so we stop here if you don't have any other questions. Any other questions? We have 3 minutes. Okay, if not, say bye and goodbye. Say bye in the chat. Aha, buyurun. Okay. Go ahead.
I can't write the chat. That's why I say that by on the voice on my phone.
You cannot, okay, the conversation part next to this hand, you can find the chat.
No, teacher. I can find the chat, but I have some connection issues. I think because my message won't go.
Oh, I see. What's your name?
Bora Ergün.
Okay, Bora. Okay, we keep it in mind, okay? You can remind me next time as well.
Thanks.
All right. Okay, thank you very much. Okay, take care. See you next time, okay? Bye-bye.